So today we're going to look at the Year 9 changing the subject. I will go through it quite quick, and I'm just going to give one solution to each question. If you want me to check your answer, please come and find me, or in lesson ask me just to check to make sure they are identical. So first one, just going to add 3xy to both sides to get 3xy, add the square root of p is equal to AB. Then take away square root of p from both sides to get 3xy is AB minus root p. And then divide both sides by 3y to get that x is equal to AB minus the square root of p all over 3y. Next, I'm going to just divide both sides by 2, nice and straightforward. Dividing this by 2 gets me 4b over 2, which can be simplified to 2b. For this one, I am going to minus 4y from both sides to get 10z minus 4y. And then divide both sides by 3, 10z minus 4y, all divided by 3. For the next one, I am going to first expand the brackets to get 4z is equal to 6xy minus 36y. Then add 36y to both sides. 4z plus 36y is 6xy. Then divide both sides by 6y to get that x is equal to 4z plus 36y over 6y. Now I notice that each of these numbers are divisible by 2. It's really important that every number is divisible by 2, otherwise this won't work. So I'm just going to divide every number by 2. So 2z plus 18y all over 3y. Okay, squaring both sides gets me 49y squared. I have to square the 7 as well as the y is equal to 6x minus 1. So 6x is equal to 49y squared plus 1, and then dividing both sides by 6, x is equal to 49y squared plus 1 divided by 6. Just square rooting both sides, x is equal to square root of 3y. Notice how the entire 3y is in brackets. See a fraction, get rid of it, so I'm timesing both sides by 4. 2y times 4 is 8y. Timesing the right side by 4 gets rid of the denominator. Adding 6z onto both sides, 3x is equal to 8y. Add 6z, so therefore x is equal to 8y, add 6z, all divided by 3. How I'm going to do this, I'm going to move everything to the right hand side except for the fraction. So I isolate the fraction. If you ever get a fraction, try and isolate it. You don't need to, it's just easier to work with. Then I'm going to times both sides by 9x. So 9x, open brackets 7z minus 10w. Now I'm going to expand, like part expand, by putting the 9 in, so 7y is equal to x times 63z minus 90w. This is just so I could get x by itself by dividing by this bracket. 7y divided by 63z minus 90w. And that is what x is equal to. Right. If I'm making x a subject, I notice x is in the denominator, so I get it out of the denominator by doing y. 2 minus x is equal to a squared x plus b. Then expand the brackets. 2y minus xy is equal to a squared x plus b. I'm going to move all of the x's to the right hand side and all the numbers to the left hand side. So doing that is going to get me 2y minus b is equal to a squared x plus xy. And then factorising the right hand side gets me 2y minus b is equal to x, open brackets, a squared plus y. and then dividing both sides by a squared plus y. X is 2y minus b over a squared plus y. To make x the subject of the formula, I first factorise out the right hand side, so I'm going to get 4u is equal to x 1 minus 6z. And then I'm going to divide both sides by 1 minus 6z to get that x is 4u over 1 minus 6z. Here I've got x's on both sides of the equation, so I'm thinking to myself, I just want x on one side, so I'm going to move all the x's to the left hand side, so I'll get 5x minus xz, and I'm going to move everything else to the right hand side, minus 4u minus 2y. And now factorising out the x 5 minus z is minus 4u minus 2y. So now I can say that x is equal to minus 4u minus 2y over 5 minus z. At this point, there's too many negative signs, it's throwing me off. You don't have to do this, but I recommend it. If I flip all the signs on the top and the bottom, then it stays the same. So all I'm going to do is positive 4y, positive 2y, negative 5, positive z. So that's going to turn into positive z, negative 5, just for convention's sake. Probably a better way of doing it. Right, times in by x plus 2, y, x plus 2. X minus 1. As soon as I have something outside a bracket that isn't what I'm looking for, I expand. Y or xy plus 2y is equal to x minus 1. Going to move all the x's to the left, all the y, everything else to the right. Xy minus x is equal to minus 1 minus 2y. Once again, factorise x y minus 1 is equal to minus 1 minus 2y. And then dividing, that gets me x is equal to minus 1 minus 2y all over y minus 1. You could do that same thing as you did up here if you wanted, but because y minus 1 is kind of positive, I'm going to leave it like this. That's fine. Right, we get rid of the square root first by squaring both sides, so y squared is equal to 3x minus 2 over x. Times both sides by x, x times y squared is equal to 3x minus 2. Move the x's to the left, so I get x y squared minus 3x is equal to negative 2. Factorising out x y squared minus 3 is equal to minus 2. And dividing by inside the brackets, I get my x is equal to minus 2 over y squared minus 3. To make the subject of the formula, this is one where you just see it a few times and then you get used to it. I'm just going to times everything by a, b and c. The reason for this being I have an a in the denominator, I have a b in the denominator, and I have a c in the denominator. So I just times everything by a, b, c. Timesing 9 over a by abc, well, the a's cancel out, but I'm left with 9bc. Timesing 8 over b, the b's cancel out, so I'm left with 8ac. And timesing negative 3 over c by abc, the c's cancel out, so I'm left with negative 3ab. General idea is basically I just have every combination of letters, but the one that was in the denominator is missing. So this one had a in the denominator, so there's no a here. This one had b in the denominator, there's no b here. This one had c in the denominator, there's no c here. Now moving b's to the left hand side, I get that 9bc plus 3ab is equal to 8ac. Factorising out b, yes, you could factorise out a 3, but I'm not going to do that because that would just make more effort in the future. So 9c plus 3a is equal to 8ac. So therefore, b is equal to 8ac all over 9c plus 3a. A very simple question, simplify it first, then divide by 2. You could do some weird factorising, but don't know why you would. Another simple question, times both sides by 12. 13 times by 12 is 156. So 156y. Another quite simple question, minus 10 from both sides, so 6x is 8y minus 5, and therefore x is 8y minus 5 over 10. If you got to this point, it's probably getting a bit easier now, actually. I think most of the hard questions are near the front. For this one, 2 ways of doing it. It's very similar to a question we saw at the start, so I'm not going to explain too much. A minus 4 is 4c over 6b. Adding 4 to both sides, a is, and I'm also going to simplify this fraction, 2c over 3b plus 4. Squaring both sides, b squared is equal to a over 5c. Times in both sides by 5c gets me 5b squared c is equal to a. Make x the subject, so I'm going to divide by 3 first to get that x squared is equal to 2y divided by 3, and then I'll square root x is equal to the square root of 2y divided by 3. Once again, the 3 is inside the square root. Make sure that's obvious. Don't just have it kind of like this, because that doesn't look like the 3 is in the square root. It needs to be in the square root. 5x times both sides by 6, 30y, minus is equal to 4x plus 2z. So I'm going to minus 2z's from both sides. 30y minus 2z is equal to 4x. Now, therefore, x is equal to 30y minus 2z all over 4. Once again, I notice that everything's divisible by 2, so I divide everything by 2, 15y minus z all over 2. Times by the denominator, because x is in the denominator, see a fraction, times by the denominator. 2y opens brackets 3x minus 7w is equal to 5z. Expand the brackets, 6xy minus 14 wy, can't remember my alphabet, is equal to 5z. Now, adding 14y or wy onto both sides, 6xy is 5z plus 14wy, and then dividing by 6y is going to get me x is equal to 5z plus 14wy all over 6y. Timesing both sides by 4x gets me 4xy is equal to 3x minus 1. Moving the 3x to the left gets me 4xy minus 3x is equal to minus 1. And then factorising out x, that gets me x 4y minus 3 is equal to minus 1. So therefore x is equal to minus 1 over 4y minus 3. We've got x in common on the right, x open brackets 1 plus 2z, and obviously that was all equal to 6u. Now dividing by that right hand side bracket, we get x is equal to 6u over 1 plus 2z. See something in a bracket and the outside isn't what I'm looking for, expand it. 3x minus 12y is equal to 4xz plus 5u. Get rid of, or move all the x's to the right. 3x minus 4xz is equal to 5u plus 12y. factorising this gets me x3 minus 4z is equal to 5u plus 12y. And now we get that x is equal to 5u plus 12y all over 3 minus 4z. Times in both sides by a plus 1 gets me b open brackets a plus 1 is equal to a plus 3. Expanding the bracket, ab plus b is equal to a plus 3. Moving a's to the left and everything else to the right, ab minus a is equal to 3 minus b. Factorising that left-hand side gets me a b minus 1 is equal to 3 minus b. And then dividing by b minus 1 gets me 3 minus b all over b minus 1. Squaring both sides gets me b squared is equal to 5a plus 3 over a. Times in by a gets me ab squared is equal to 5a plus 3. Then minusing 5a gets me ab squared minus 5a is equal to 3. So a is equal to b squared, or a times b squared minus 5 is equal to 3. And then a is equal to 3 open or divided by b squared minus 5. Times in by x, y, z. Note I'm making y the subject. So 7yz is equal to 7xz plus 5xy. I want y the subject, so I'm going to move all the y to the left. 7yz minus 5xy is 7xz. Now factorising out y, 7z minus 5x is equal to 7xz. And dividing by the bracket gets me 7xz all over 7z minus 5x. So that's a z there. I'll make it a bit clearer. Z. Making x the subject here. 3 minus 3q. You'll note Mr. Bell has a tendency to put the harder questions at the start and the easier questions at the end. So sometimes if you ever see it says Mr. Bell on the front page, try the back first. A is 3b plus 11. 8. A is 5b minus 2. So A is 5b minus 2 all over 8. I'll expand this time. xy plus 12y is 5z. And then minus 12y. And then divide by 18y, 5z minus 12y over 18y. Right, squaring y squared is equal to 6x plus 4z over 5. Times in by 5y squared is 6xz, or 6x plus 4z. Minusing 4z and then dividing by 6, I'm just going to do it in one step. X is equal to 5y squared minus 4z all divided by 6. I'm going to start speeding up now just because x is square root of 2y. Times by 5 gets me 30y minus z gets me, so if you want to know how I'm actually doing this, I'm timesing by 5, so I'm going to say x is 6y times 5 is 30y. Then I'm going to minus z, and then I'm going to divide by 2. Okay. This one, bit trickier, but we saw a similar one earlier. Let's go for times in everything by 3a, so 7b 8d times 3a is 24ad, and 7c times 3a is 21ac. Then moving a's, let's go to the left-hand side, so 24ad minus 21ac is equal to negative 7b. And now I'm just going to factorize and get that a is minus 7b over 24d minus 21c. I think this is a typo. I'm going to ignore that and just pretend it looks like that. I'm going to times everything by 2 to get rid of the 2, so 6 plus 2 pi x is equal to x plus 2b. Moving the x's to the left and the 6 to the right gets me 2 pi x minus x is equal to 2b minus 6. Then factorize divide, I'm not going to show it. X is equal to 2b minus 6 all divided by 2 pi minus 1. A is equal to 3d all over 4 plus 2c. Okay, expand 6a minus 24b is equal to 4ac plus 3d. Move a's to the left, so 6a minus 4ac is equal to 24b plus 3d. Then divide by 6 minus 4c. Once again, factorize if you want to see that step. I'm not going to bother anymore. 3d all over 6 minus 4c. Alright, finally getting towards some interesting questions again. So I'm going to multiply by 2x minus 1. That's going to get me 2xy minus y. I expanded, I didn't bother showing that though. 3x minus 2. Then moving the x's onto one side, 2xy plus 3x is y minus 2. And then x therefore is equal to y minus 2 over 2y plus 3. Squaring b squared is equal to 5a minus 6 over 2a. So 2ab squared is equal to 5a minus 6. 2ab squared minus 5a is equal to negative b. Factorising out a and then dividing gets me negative b over 2b squared minus 5. And then this one, 4yz is equal to 2xz plus 5xy, times in everything by xyz. Making x onto the left at 4 yz minus 2xz is equal to 5xy. And then once again factorise and divide, or just go 5xy all divided by 4y minus 2x. Okay, and then yeah, that's it. Done. All the answers are also below if you want to double check, and actually they come with solutions as well on how you can do it if you want to do it a different way or have a look. Yeah, obviously I've missed out square roots, plus or minus, because I'm an idiot. Please don't forget that whenever we square root something that has a even power, we need a plus or minus. So please do change them. Alright, sorted.